What if you were to colonize Mars, space program, exploring Mars? You will not only be able to imagine all of this, but also see it in this video. Welcome to the What If Lab channel. Sit back and let's begin. First, you will need to undergo training at NASA, starting with vestibular training aimed at ensuring your stability against changes in gravity and orientation. One of the key methods used is the centrifuge. You will undergo tests on it, experiencing forces of up to 9G, which is 9 times the force of gravity. This will help prepare you, as during the rocket launch, you will experience forces ranging from 3G to 4G, meaning your body will feel 3 to 4 times heavier than its normal weight. Such forces will cause changes in your circulation, affecting your brain and other organs. Training also includes the use of zero-gravity simulators, such as the multi-axis trainer, which will rotate you in different planes to help you acclimate to disorientation. Additionally, there will be water training in a large pool known as the Neutral Buoyancy Laboratory, which will play a crucial role in helping you adapt to zero-gravity conditions. Next comes physical training, where you will engage in strength workouts using your body weight, free weights, and machines. Cardiovascular exercises such as running, stationary biking, and using ellipticals will help improve your endurance. Psychological preparation also plays an important role in the training process. You will undergo training in stress and conflict management techniques to work effectively in confined spaces. Simulations of long-duration missions conducted in isolated environments, such as Mars Society or high seas, will help you prepare for life in a confined space for an extended period. Don't forget about training to operate equipment. You will practice on simulators, learning to work with various systems of the spacecraft, including controls, navigation, and communications. Practicing in conditions close to zero gravity will allow you to hone your skills in handling scientific equipment and conducting experiments. Unfortunately, at this moment, there is no spacecraft ready to send humans to Mars. However, to illustrate what a launch would look like, I will use NASA's Orion as an example. Let's start with the preparations for the launch. First, a comprehensive check of all systems and equipment is necessary, including engines, navigation systems, and life support systems. Next, Orion is fueled with liquid oxygen and rocket propellant, usually RP-1. A few minutes before the launch, the countdown begins, the ship's systems go into readiness mode, and you and the other astronauts take your places in the cabin. Orion is typically launched using a rocket booster, such as the Space Launch System, SLS. A few seconds before launch, the SLS engines are activated, creating a powerful flow of gas that propels the rocket upward. In the first phase of the flight, the SLS rocket uses its first stage. After the fuel is depleted, the first stage separates from Orion, reducing weight and allowing it to reach speeds of around 28,000 kilometers per hour. After activating the second stage, Orion accelerates to about 33,000 kilometers per hour, allowing the spacecraft to enter a low Earth orbit. Once the required altitude and speed are reached, Orion separates from the rocket booster and enters Earth orbit, after which it will set course for Mars. You and the other astronauts will spend time in microgravity, where you can conduct scientific experiments and interact with the equipment. You must also be prepared to troubleshoot any issues outside the spacecraft. For this, you will wear a white suit that reflects sunlight and protects against overheating. However, in outer space, there is a vacuum that makes it difficult to dissipate heat from the human body. Without an effective cooling system, you could overheat inside the suit, as you emit about 150 watts at rest and 300 watts during active work. Therefore, the suits include special tubes that circulate cold water, allowing for temperature regulation inside. When landing on Mars, you will encounter the challenges of low gravity. The gravity on Mars is approximately 0.38 g. For comparison, the gravity on the Moon is about 0.16 g. This weak gravitational pull makes it impossible to retain an atmosphere on the planet, and any attempts to create an artificial atmosphere would be futile, as the planet cannot hold gases on its surface. This poses serious challenges for colonization, as you and the other astronauts are exposed to solar radiation. On Earth, our atmosphere protects us from solar radiation, and if compressed, it would be equivalent to a density of 6 meters of soil. Therefore, to protect against solar radiation on Mars, you would need to burrow at least 6 meters deep to create underground stations that can provide safe living conditions. Fortunately, ice reserves have been discovered beneath the surface of Mars. This finding provides the opportunity to extract water, which you can split into oxygen and hydrogen through electrolysis. The resulting oxygen can be used to create an artificial atmosphere within an underground air dome, ensuring the necessary conditions for breathing and living. And here we are at the end of the video. If you enjoyed the flight to Mars and want to embark on a journey to other planets, leave a comment and I will make a new video. I won't say goodbye. See you next time.